All right, so I'm going to share my screen. If you saw my announcement this morning, and I also mentioned this yesterday, today I'm just going to be answering any questions that you have about the quiz. I'm feeling pretty sick today, so I don't know how long I'll last. But I got I think 3 or 4 questions that I definitely wanted to go over. And I also wanted to just talk briefly about the quiz. And if I start sneezing or coughing uncontrollably, I'll probably just end it early. So the first question that I got this morning was, and someone else has asked about this too, so this was a common question that people were having trouble with. This is from section 5.1. Oh no, I just ripped my textbook. All right. This again is from section 5.1. And I was going back over the quiz last night just so I had a good idea of what was on it before we started today. And there wasn't one exactly like this. And what I mean by that is there wasn't a binomial question that was less than, but there is one that's very similar to this type of question, but I think it's a Poisson distribution. So I definitely want you to make sure that you know how to deal with these problems that have less than, have the less than inequality. So this says, assume the random variable x has a binomial distribution with the given probability of obtaining success. Find the following probability, given the number of trials and the probability of obtaining success, round to 4 decimal places. All right, so it's asking us to find this probability, the probability that x is less than 2 if the number of trials is 5 and the probability of success is 0.8. All right, so we're looking for the probability that x is less than 2. Now, let me open up my document camera. One thing that I did this morning when I got here was I was thinking about the guide for probability distributions and how most of you probably won't be able to print this out. So what I did was I went in, and every question on the quiz has a clickable link so that it'll pull this table up, and you can just scroll through it while you're in the quiz. So you do not have to print this out. It'll be, available through a clickable link in the quiz. All right, so it told us in the problem that this was a binomial random variable. So we know we're going to be using this binomial row. All right, so let's look over here at our calculator hints. All right, so it shows, or it tells us that there's 2 different types of problems, or 2 different types of probabilities that your calculator is programmed to deal with. Your calculator can deal with these probability that x is equal to a number problems, and it can also deal with the probability that x is less than or equal to a number. Now, the other inequalities that we talked about, remember those were greater than or equal to, and less than. Your calculator is not programmed to deal with these type of inequalities. So we have to make some adjustments to our probability statement so that we force it into one of these forms. And I showed you how you could do this either way. The long way is to think about, well, okay, I'm looking for the probability that x is less than 2. So that would be x is equal to 1 or x is equal to 0. So you could just add up those individual probabilities. Or a little bit shorter method is to convert it over into a less than or equal to problem so that we can use this binom CDF function. And I was also thinking about this morning, I never told you what PDF and CDF stand for. If you're curious, PDF stands for probability density function. It just refers to the formula. And then CDF refers to cumulative density function. And cumulative just indicates that we're working with this inequality here. So it's like accumulating area or accumulating probabilities. All right, so I was just thinking this morning that I never told you that, and you may be wondering what PDF and CDF stand for. So PDF is probability density function, CDF is cumulative density function. Now, how I showed you, or how we did this yesterday and the day before, was I drew you a little number line. Let me try that again. All right, that's better. And I said, okay, well, binomial probabilities or binomial random variables are always going to start at 0. You could have 0 successes, and they always end at whatever the number of trials is. So that's the maximum value of your binomial random variable. And so let's just fill in the tick marks in between 0 and 5. So it'd be 1, 2, 3, and 4. Okay. Now, this probability is asking us to find the probability that x is less than 2. Not less than or equal to, just the probability that x is less than 2. Now, since this is a discrete random variable, anything that's less than 2, you're going to have to jump down to the next whole number. So it's going to start here at 1 and go to the left. So it's this area right here. There, that probability is what we're looking for. And so I told you guys that this number line kind of gives you a visual way to see where your new starting point is going to be. So we could convert this into our correct format that we need. We could write probability that x is less than or equal to 1. So starting at 1, everything less than that. All right, and then now that we have it in the correct format, let me refer back to our guide for probability distributions. Now we can use this binom CDF function since we have it in this correct format. It's in the form of less than or equal to. So we're going to do binom CDF, and remember to get there, you go to second vars in your calculator. So get your calculator. Remember I told you I like to start off with my screen cleared out. If you accidentally have something typed in here and then you do second vars, it's going to mess your answer up. So you always want to start off with your screen cleared out. All right, so second vars, scroll way down to binom CDF. CDF because it's the less than or equal to. So that tells us which one to use. So hit enter. Mine comes up with this additional screen where I type in the trials, the probability of success, and my x value. But you may have to type this in manually. So my number of trials is 5. Probability of success is 0.8. My x value is 1. So my new x value is right there is 1. So if you type this in manually, this is what you should have. Then just hit enter, and there you go. Very small number, 0.0067. We don't have to round anything up because this 2 tells us we're just going to keep that number the same. All right, so that's 0.0067. Very, very small probability. And remember, anytime, this is like a good way to eliminate answer choices on the quiz. So again, imagine if this is a multiple choice, multiple choice quiz. And maybe here's some examples of answer choices I might put in here. I'm just going to make up some other numbers. Now, if you're looking at this and these are your answer choices, you can automatically eliminate part D. because, or answer choice D, because probability should always be between 0 and 1. So think about that as you take the quiz, and think about how you can eliminate some of your answer choices to narrow down your options for that particular question. So just keep that in mind, because I think as I went through them last night, I do remember seeing some numbers that were bigger than 1. Let's see, Rhonda. When it's greater than or greater than or equal to, is that when you use the 1 minus? Yes, that is exactly right, Rhonda. So if you have a greater than problem, if your probability looks like this, if it looks like probability that X is greater than 5 or something like that, then that's when you do the 1 minus binom PDF or binom CDF. Yes, that's exactly right. And I do remember, I think I seen one of those on the quiz. You're welcome, Rhonda. Let me think if I did anything on here last night. I did add this tab. Let me go to student view, because I've got all the future stuff that's hidden right now. But if you go to content, I put this extra, I think they're called modules. I put this extra module on here, so it gives you a direct link to that Hawks page where they have all these free videos. So if you need a quick overview of like the Poisson distribution, you could just go here and watch. They're usually like between 5 and 6 minutes. So I think I added that yesterday. And I did finish the answer key to the practice quiz, so I will go upload that right after we finish today. Let me show you. I talked about how the guide for probability distributions would be in a clickable link, but another thing that will also be in a clickable link is the formula sheet. So these are the 2 things. They'll be on every single question. You'll be able to click on a link and it'll take you to this formula sheet. It's broken up by unit. So these are the unit 2 formulas. Scroll on down. These are the formulas specific to unit 3. So that's all your like complement rule, your addition and multiplication rules, your conditional probability formula, all that stuff. So this will be in a clickable link on the quiz on every question, and this guide for probability distributions, you'll just click it and it'll pop right up. Sorry for the heavy breathing and nasally sound. All right, so this was another one, and I actually, last night I was, when I was writing the answer key to the practice quiz, there's one like this on it, and I kept thinking there has to be a shorter way of doing this. And so this morning I got on to Hawks, and I just looked and seen what they had like for the tutor, like solution guide or whatever on the practice version, and they did it the exact same way that I did it. So that made me feel a little bit better that I wasn't just forgetting how to do this. But let's look at this question. It says, and this is one that I do remember seeing on the quiz. I think this was section 4.2. And I think the difference here is just this piece right here, the difference on the quiz. So it'll look exactly like this, and then this may be a little bit different. So it says a standard pair of 6-sided dice is rolled, so 2 dice. What is the probability of rolling a sum? So sum means you're going to add up your dice rolls. What's the probability of rolling a sum less than or equal to 10? Okay, so let's think about rolling 2 dice. So this is our experiment, rolling 2 dice. All right, so here's like your, right now what we're going to do is we're going to figure out what's the total number of options that you could roll. So that's your roll 1, here's your roll 2. And remember the fundamental principle of counting told us that we can find the total number of outcomes by just taking our first roll for our first event, figuring out how many options there are for it. So if it's a 6-sided dice, there's 6 options for which number could pop up. And then for our second roll, again, same thing, there's 6 options for the outcome. And then you just, the fundamental principle of counting, or the multiplication principle, multiplication principle tells us to just multiply these. That tells us there's 36 total outcomes for rolling 2 6-sided dice. Now that's going to help us because, you know, probability is always like frequency over total. All right, so that'll help us whenever we go to find the probability. All right, so we're looking for the probability that the sum is less than or equal to 10. All right, so let's think about all of the different options for what you could have. All right, so first you could have, let me write this way, the sum equal to 10 plus the probability that the sum is equal to 9. We're just going all the numbers that are less than 10, less than or equal to 10, excuse me, plus the probability that the sum is equal to 8. We're just going to keep going down, plus probability that the sum is equal to 7. I'm going to scroll out so I can fit this all in here. Plus the probability that the sum is equal to 6. Plus the probability that the sum is equal to 5. Now you're going to want to think about this, like what's the lowest that the sum could go. So remember, we're rolling a dice, so the smallest number for each of these would be 1. So the lowest that the sum could go would be 2. So that's where we're going to stop. Plus probability that the sum is equal to 4. Plus the probability the sum is equal to 3. One more time. Sorry, I know it's probably getting small. We're going to zoom into each individual piece as we find these probabilities. Plus the probability that the sum is equal to 2. Again, that's the smallest that the sum could be, because each dice would have a 1 on it. That's the smallest it could go. All right, so that's what we're going to calculate. Now this looks like a lot, but it's going to get repetitive, and we'll be able to start quickly going through all of the possible outcomes. All right, so let's start. I'm going to give you a second to finish writing that if you are copying this down on your paper. Now on the homework, they do this same exact thing. They just do it in a more condensed format, so they're not showing like every single step of their work. And I think they're using a variable like X to represent the sum. But this is what you'll see in the homework if you go to like the tutor option on the practice for section 4. For this problem on section 4.2. All right, so I'm going to start over here at the probability that the sum is equal to 10. All right, so let's think of all the ways that you could roll a sum of 10. All right, so you could roll, let's see, a 1 and a 9. You couldn't roll that because the highest you could roll is a 6. All right, let's see, 2 and 8, that wouldn't work. 3 and 7, that doesn't work. But you could roll a 4 and a 6. Or you always want to go ahead and list out the opposite. You could roll a 6 and a 4. Or you could roll a 5 and a 5. We don't write this one again because it's the exact same thing. All right, so this is 3 out of the total number of outcomes. So that's 3 out of 36. Plus. Now let's think about all the ways you could roll a sum of 9. 1 and 8, that wouldn't work because the highest you could roll was a 6. 2 and 7, that doesn't work. But you could roll a 3 and a 6. Or a 6 and a 3. Or a 4 and a 5. Or 5 and 4. All right, so that's 4 out of 36. Again, 36 being the total number of outcomes. This is 3 out of the total number of outcomes. 4 out of the total number of outcomes. All right, so think about all the ways you could roll an 8. You're about to see a pattern emerge. that'll help you maybe save a little bit of time. So rolling in sum of 8. Let's see, 1 and 7, that doesn't work. But you could roll a 2 and a 6, or a 6 and a 2. Or you could roll a 3 and a 5, or a 5 and a 3, or a 4 and a 4. So that's 1, 2, 3, 4, 5. So that's 5 outcomes out of the total 36 outcomes. So you see what's happening here? 3, 4, 5 plus. Let's think about how you could roll a 7, a sum of 7. You could roll a 1 and a 6, or a 6 and a 1, a 2 and a 5, or a 5 and a 2, or a 3 and a 4, a 4 and a 7, 4 and 3. And then that's it. We're back up to 5 and 2. So 1, 2, 3, 4, 5, 6. 6 out of 36. All right, so see what's happening? 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36. Now let's see what happens with the next one. All right, so rolling a 6. You could roll a 1 and a 5, or a 5 and a 1. You could roll a 2 and a 4, or a 4 and a 2, or a 3 and a 3. So that's 1, 2, 3, 4, 5. So now it's starting to go back down. So it went 3, 4, 5, 6, 5. Now I bet you can guess what's going to happen from here. It's going to go back down, and you could write these out if you needed to, but it's going to go back down. It's going to start going back down. This is pretty cool. You can make a little table. If you were in my quantitative reasoning class, you may remember the little table that we made that illustrates this pattern. But it goes 3, 4, 5, 6, and then starts to go back down 6, 5, 4, 3, and then 2 out of 36, and then 1 out of 36. And again, this makes sense, right? Because the only way you could roll a sum of 2 is to roll a 1 and a 1. All right, so now we have to add all of these up. So let's see. Let me get my calculator. So 3, now the little trick that we talked about before, if they all have the same denominator, you can just add up the numerators and then divide by 36, but I'm going to type it in the long way. 3 out of 36 plus 4 out of 36 plus 5 out of 36 plus 6 out of 36 plus 5 out of 36 plus 4 out of 36 plus 3 out of 36. Take your time doing this. You don't want to mess up. 36 plus 1 out of 36. So very high probability here. So you're very likely to roll, whenever you roll 2 dice, that your sum is less than or equal to 10. So that's what that means. All right, so this one would be 0.9167. So we would have to round up because this is a 6. So 0.9167. And on the quiz, everything is, all the questions that ask for probabilities, they're all given in decimal form. And they're all multiple choice, so you won't have to type in any of your answers. Okay. And like I said, the only way that I know to do this that's shorter is to do that little table. And I might Google one and pull one up to show you. I'll just Google table rolling 2 dice. Yeah, so this is like all the possible outcomes of rolling 2 dice. And so like you can see the sum here, 1 plus 1 would be 2. These 2, 2 plus 1 would be 3. 1 plus 2 would be 3. So it kind of lines up and you can count the outcomes. That's the only shorter way I know to do this. there's no like shortcut method for finding this probability. It just takes forever. But I would say that this is probably the question on the test that would take you the longest. This is the most work. And I'm pretty sure that the sum here is less than, it's a smaller number than 10. It's not that big. All right, and then I had one more that I wanted to cover. Nobody asked me about this one, but I wanted to cover it anyway because I felt like we only did one of these problems together in one of the live sessions, and we did not ever really do a problem like this again. So let me see if I can find it. Still looking. Oh, it was not on the practice quiz. It was on the actual quiz. So let me pull up from the homework which one it was. I know I'm giving away like everything that's on the quiz, but I feel like if you're watching all these videos, then you deserve a little hint for the quiz. All right, I think it was in section 4.4, but we'll see. I'm going to pull up this is like the teacher's side of Hawks where I add all the questions. Yeah, here it is right here. This one about the password. All right, so I'm just going to copy this over into the whiteboard. So this is from section 4.4. It always puts the numbers twice. I don't know why. All right, there we go. This is one that was on the quiz that I thought I'd only talked about this question one time, and I wanted to make sure, and it wasn't on the practice test, so I wanted to make sure that you had seen it again. All right, so it says, let me write again. This is in section 4.4. You need to have a password with 5 letters followed by 4. We're going to take out the even. We'll just say 4 digits. You need to have a password with 5 letters followed by 4 digits between 0 and 9 inclusive. Inclusive just means that you can use 0 and you can use 9. If it had said exclusive, that would mean you can only use like 1 to 8. So that means like exclude the endpoints. But this one says inclusive, so include the endpoints. If the characters and digits cannot be used more than once, so well, we say that would be like without replacement. How many choices do you have for your password? Now, the way that I did this in class, I'll give you a second if you're writing this down. Let me not get ahead of myself. All right. All right, so it says you need to have a password with 5 letters followed by 4 digits between 0 and 9 inclusive. If characters and digits cannot be used more than once, how many choices do you have for your password? So let's think about this. This password is going to be 9 characters, right? Because it's 5 letters. It's 5 letters followed by 4 digits. So it's going to be 9 characters altogether. So this is going to be our password. Now, the way I told you guys in class, there's a way that you can do this using like the combinations and permutations, but to me, it's easier to do it this way. So I'm just going to write down a little blank space for each one of the characters in my password. So here's my 5 letters. These are all letters. And then I have 4 numbers. 1, 2, 3, 4. And again, these are numbers between 0 and 9. Now, we know that you are not allowed to use these letters and digits more than once. So once we use a certain letter, we can't use it again. All right, so let's think about how many choices we're going to have for each letter as we go through our password, and each number as we go through our password. All right, so here's our first letter of our password. We have 26 letters in the alphabet. All right, so there are 26 options for our first letter. Now let's say that we chose the letter A. We cannot use that letter again, so now we only have 25 choices for our next letter. And similarly, after we choose that second letter, we only now have 24 options to choose from, 24 letters to choose from, and then 23, and then 22 letters to choose from. Now we're starting over. We're doing numbers now. So we have numbers between 0 and 9. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 choices. So 10 choices. All right, so for my first number, I have 10 choices. Then once I've chosen a number, say I choose the number 1 here. I can't choose that number again, so now I have 9 choices. Then I have 8, and then I have 7. And remember the multiplication principle, or your book called it the fundamental principle of counting. Fundamental principle of counting. This principle tells us that if we are counting up the number of outcomes, all we have to do is just list the number of possible outcomes for each individual event. So that each individual event here is like a character of our password. And then we just multiply those numbers. So I'm just going to write little multiplication dots in between all of these. And now we're going to multiply them. So let's grab our calculator. Let me scoot this over. Oh, my camera's back. Maybe that's why it wouldn't work. I don't know. All right, let's see. All right, so I'm going to multiply this all out. Take your time. You don't want to mess anything up here. 26 times 25 times 24 times 23 times 22 times 10 times 9 times 8 times 7. And now it gives me this really weird number. You remember we've seen this before, and I told you if you see this, some of your calculators may show this up different. It may show you as like times 10 to the 10th power. That's like scientific notation. My calculator just says 3.9783744 E10. This little E tells us we're going to have to move the decimal. The number after E tells us if you should move it to the left or to the right, and it tells you how many spaces to move the decimal. So since this is positive, it means to move the decimal to the right 10 places. So if it's positive, that means move the decimal to the right. All right, so we're going to move it to the right 10 places. So let's see, that's 1, 2, 3, 4, 5, 6, 7. And then we run out, so we're going to add in 3 zeros after that. So it'll be 3 zeros after that last number. All right, so that's going to be, let me scoot this over a little bit. All right, 397, 837, 44, and then remember I have to add 3 zeros after that. So 1, 2, 3. So remember my decimal started off right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was how many spaces I was supposed to move the decimal to the right. Now I can go back in and add in my commas, so comma every 3 places. So that's 39,783,744,000. That is how many choices you would have for your password. All right, so I think it's pretty simple. You just write out the number, write out your little blank spaces for all your characters, and then fill in how many options you have for each one. That's going to tell you your total number of choices for your password. So make sure you know how to do this one. Very important. I also wanted to mention that there is a bonus question on the quiz. You don't have to do it, but if you do it and you get it wrong, it's not going to count against you. I think that's the only one where you actually have to type in the answer. So if you want to just try it, it will not count against you, but you don't have to do it if you don't want to. It's just like let's see, I think let me think of how many points it would be worth. I think there's 15 or 16 questions on the quiz, so it's about a 5 or 6 point bonus. But it's up to you. It's not terribly difficult. It's just one that I think we only covered it like one day, and so I thought I'd throw it on there. Let me think if there's any other questions there's one from section 5.2 that people, or no, 5. Let me think what section it is. It is 4.3. And it was about like graduate degrees. Feel free to interrupt me if you want to ask me a question. I'm just like talking over here. Okay, here it is. It's this question right here. I guess it's a 2-part question, so let me copy that whole thing. All right. Like I said, for some reason it always copies the numbers twice. I don't know why. Okay. So I've had people ask about this question, like I would say at least 4 times people have asked about this. I've had at least 4 different people ask about it. So I wanted to go over this one also. All right, so it says, out of 441 applicants for a job, 235 have over 5 years experience, and 106 have over 5 years experience and have a graduate degree. Okay, it says, what is the probability that a randomly chosen applicant has a graduate degree given that they have over 5 years experience? Let me read that again in case you zoned out. What is the probability that a randomly chosen applicant has a graduate degree given that they have over 5 years of experience? Enter a fraction or round to 4 decimal places. All right, so when we see this word given, that should give you a big hint that this is a conditional probability problem. So this is a conditional probability problem. Now, there's a formula for conditional probability. It's on the formula sheet. This is what it looks like. It says the probability of, let me see which one I use. I can't remember if I use E given F or F given E. Let's just look. Right, there it is. Yeah, F given E. Okay. Probability of F given E is equal to the probability of F and E. You could also write this as E and F. It's the same thing. You can switch the letters around. Divided by the probability of the second letter, which is E. All right, so in ours, this is what we're looking for. We're looking for the probability that they have a graduate degree given is represented by that long straight line, given that they have over 5 years experience. All right, so we're going to follow the outline of this formula. So probability of F given E. Ours is graduate degree, so F is graduate degree, and E is over 5 years experience. Okay, so F is graduate degree, E is over 5 years experience. So that's going to be equal to probability of F and E, so probability of graduate degree and over 5 years experience. Abbreviating here because I'm running out of room. Oh, goodness gracious. All right, and then our formula says divided by the probability of the second one. So probability of over 5 years experience. All right. Now the only thing we have left to do is we just need to plug in our numbers. All right, so the numerator wants to know what's the probability that an applicant has a graduate degree and over 5 years experience. I'm about to sneeze, so I may be interrupted here. Graduate degree and over 5 years experience. All right, so let's look at our numbers up here. This said, out of 441 applicants for a job, 235 have over 5 years experience, and 106 have over 5 years experience and a graduate degree. That's what we're looking for. We're looking for the probability that they have a graduate degree and over 5 years experience. So graduate degree and over 5 years experience. So that was 106 out of the 441. All right, so numerator is 106 out of the total 441 applicants. All right, big division sign there. Now let's look at the denominator. The denominator says, what's the probability that an applicant has over 5 years experience? So it told us that out of the total 441 applicants, 235 had over 5 years experience. All right, so let's plug that in the bottom. Probability that an applicant had over 5 years experience was 235 out of the total. Now, if you remembered the little trick I told you for when you have a complex fraction like this is called a complex fraction. When you have a fraction divided by a fraction. If you have a complex fraction and the numerator, this part here, and the denominator have the same denominator, the little trick, and this is like a huge shortcut, is that it's always going to simplify to be 106 over 235. So it's always the numerator at the top divided by the numerator at the bottom. But if you don't remember that, that's totally fine. We can do this in our calculator. So you just want to put parentheses around the top fraction. So like put parentheses around this fraction and then parentheses around that fraction. All right, so 106 over 441 divided by parentheses around the bottom, 235 over 441. If we make that into a fraction, it's 106 over 235. And again, all the questions on the quiz will, the answers will be given to you in decimal form. So make sure you know how to convert between decimals and fractions on your calculator, just in case. On this calculator, which is the TI-84, it'll be the same for a TI-83. You click Math, and then it's these first two options here. The first one says Convert to a fraction. Second one says Convert to a decimal. So that just puts it back in decimal form. If you have a TI-89, it's a little bit different. If you email me, I can tell you how to do it for a TI-89. There's like a little diamond button at the bottom that you have to press. All right, you guys. I'm getting lightheaded, so I think I'm going to have to stop here. Thank you for listening to me be so snotty today. Oh, you're welcome, Robin. And thank you. I think it's just allergies. But if I don't post an announcement on Monday, I might have a new teacher. No, I'm just kidding. Not really. I'm not on death's door yet. I'm just having a cold. You're welcome, Rhonda. Okay, now the quiz opened this morning at 12 a.m. But it doesn't close until next Wednesday. So I know most of the people who take the quiz for some reason like to wait until next Wednesday. But if you have any questions, it's better to get them to me this week, because next week my inbox just gets flooded with questions. Like I usually get like 70, between like 50 and 70 emails a night between like Tuesday and Wednesday. So it's better if you have a question to get it to me this week, and there's a better chance that I can get back to you in a timely manner. But if you do have any questions, please let me know. I'm happy to help you however I can. I won't be back in the office this week, so I won't be able to video chat and like show you my calculator and stuff, but I can always just write you up something quick on my iPad, record you a video on my iPad and send it to you that way. All right, but thank you all so much for coming today, and I will talk to you again on Monday, or through email. I'll talk to you sometime before that, possibly. I hope you all have a great day.